This is a quick proof of the cosine rule. So we're starting with our standard triangle, ABC with big letters for the angles, and then little ABC opposite the corresponding angle for the sides. It's not a right-angled triangle necessarily. It could be a right-angled triangle, but it doesn't have to be. So I'm just going to worry about angle A in this proof, and then the three sides. Side A, opposite angle A, and then the other two, B and C. So the first thing I'm going to do is drop a line down from the top, a vertical line. So the way I've arranged this, side C is along the ground, horizontal. So I drop that line down from the top, and it's the height of the triangle, and it's at 90 degrees to the base, which is C. So I'm going to label the length of the left-hand side right-angled triangle as X. So the whole base of the big triangle is C, but I've labeled the part of it that makes this right-angled triangle as X. Then I've got another right-angled triangle on the right-hand side, so the length of that is C minus X. Now, by definition, X over B is cos A. So I'm looking at the right-angled triangle on the left here, and it's got an angle A there. Remember, cos equals adjacent over hypotenuse. So in this case, that's X over B. So X over B is cos of A, just by the definition of what cos is. I'm going to multiply both sides of that by B to get X is equal to B cos A. So this length of the base of the left-hand side right-angled triangle, X, is also equal to B cos A. B times cos A. And I'm going to use that later. So I'm going to do some Pythagoras now. I've got a right-angled triangle on the left here. And Pythagoras says that the hypotenuse, the square on the hypotenuse is equal to the sum of the other two squares. So maybe confusingly, I've got the height labeled as h here, so that h is standing for height and not hypotenuse. But in this triangle, h squared plus x squared equals the longest one, b squared. And then just taking the x squared away from both sides, I've got h squared is equal to b squared minus x squared. So this squared equals this squared minus this squared. It's just rearranging Pythagoras a bit. And I'm going to leave that like that for the moment and have a look at the other smaller triangle, which is also right-angled. And again, Pythagoras. And I'm going to say h squared plus c minus x squared equals a squared. So that's just putting in the three sides that we've got as they're labeled into Pythagoras' theorem. And taking away the bit here with brackets from both sides, h squared equals a squared minus c minus x squared. So this squared equals this squared minus this squared. It's just Pythagoras rearranged a bit. Well, having done that to both right-angled triangles, I've now got two expressions that are both h squared equals something. So because they're both equal to h squared, they're both equal to each other. So b squared minus x squared equals a squared minus c minus x squared. So I'm just going to move that up a little bit to give myself a bit more working space. And then I'm going to multiply out that c minus x squared. So remember, c minus x squared means c minus x times another c minus x. So when I multiply all of that out, I'm going to have c times c, c times minus x, the other minus x times the other c, and minus x times minus x. So the c times c gives me c squared, the c times minus x, and then the other minus x times the other c gives me minus 2cx, and minus x times minus x gives me x squared. Now put that all in brackets because it had a minus in front of it, so I've got to remember that it's minus all of that. So if I want to write that without the brackets, it's minus everything in the brackets. So minus c squared minus minus 2cx makes plus 2cx, and minus x squared. Well, I've got a minus x squared on both sides, so I could add x squared to both sides and get rid of that. And then I could add c squared to both sides to get b squared plus c squared equals a squared plus 2cx. Point of this being I'm aiming to get towards the cosine rule. I've taken away the 2cx from both sides to get b squared plus c squared minus 2cx equals a squared. So it's starting to look like the cosine rule. And remember that x there is equal to b cos a. So I'll swap that x for b cos a, and then we've almost got the cosine rule. B squared plus c squared minus 2cb cos a equals a squared. It just needs a little bit of tidying up to give me, so I've just swapped the left for the right, so a squared equals b squared plus c squared minus 2, and then I've swapped around the b and the c, so 2bc cos a, which is the cosine rule.